Hello student, this is Dhanjit and you are watching my YouTube channel Reaction Concept. Student, we have already discussed 3 colligative property. So for now, first one is relative lowering of vapor pressure, elevation of boiling point and depression of freezing point. Numerical from the latter 2 colligative property, that is elevation of boiling point and depression of freezing point. Based on these 2 colligative property, there are some numericals are there, okay, and numericals are similar to each other. So we'll discuss some problem based on these 2 colligative property. This is the first problem we are discussing here. In the problem, it is given that when we add a calcium hydroxide solute in an amount of 3.7 gram, this is a non-volatile solute, we are adding to a volatile solvent, that is water. How much water we have taken? There is 300 gram of water, and it is said that the calcium hydroxide is dissociated up to 90%. Okay, this much information you have given. In the question, it is asked to find out what will be the elevation of boiling point of the solution, boiling point of the solution, depression of freezing point of the solution, and what will be the freezing point of the solution. These 3 data you are supposed to calculate. So first, what you have to do, first you convert this composition of the solution into molality, that is molality of the solution should be calculated. So molality is given by weight of the solute divided by weight of the solvent into 1000 divided by molar mass of the solute. So weight of the solute, it is 3.7 gram divided by 300 gram, 1000 divided by 74. If we calculate this one, we'll get a value of 0.16 molar. So molality of this solution would be 0.16. So we have to calculate the elevation of boiling point of a solution. So elevation of boiling point of a solution, del TB, it is given by I into Kb into molality. So I would be 1 plus 3 minus 1 into alpha. Kb would be, for water, Kb it is given 0.52 and molality is 0.16. okay, so alpha would be 0. This would be 0.9 into 0.52 and 0.16. so if we this is the I value. If we calculate this one, we will get a value that is 0.24. okay, this is the elevation of boiling point. It could be degree Celsius or Kelvin, since it is a temperature difference. So boiling point of the solution would be del TEB, it is given by what? Temperature of the solution minus temperature of the solvent. So del TB, it is 0.24. we have to calculate the boiling point of the solution, and boiling point of water, it is 100 degree Celsius. So TS would be 100.24 degree Celsius. This would be the boiling point of the solution. And we will discuss now the freezing point of the solution, del TF. It is given by IKF into molality. I I already know it would be 2.8 into Kf, it is 1.86 for water, and molality of the solution it is 1.6. If we calculate this one, then we will get 0.83. This I value is calculated from this one. Okay, if we calculate this one, then we will get I equal to 2.8. Now we will calculate, this is the elevation of boiling point. This could be degree Celsius or in Kelvin unit. So if we calculate the freezing point of the solution, then it will be this much. So it is 0 degree Celsius minus 8.83. So minus 0.83 degrees Celsius, it is the freezing point of the solution. Okay, so this is how you have to solve this problem. What we have done, we just first calculate the molarity of the solution, then we put the value on the respective terms of the formula that we already discussed in elevation of boiling point and depression of freezing point. So this is a problem. This is a very simple problem, and this problem is related to both freezing, depression of freezing point and elevation of boiling point of the solution. So in the question, a solution, aqueous solution is given, that is a solution of water. Okay, solvent part it is water. And boiling point of the solution, it is given that 100.68 degrees Celsius, and it is asked to find out the freezing point. I missed the point, freezing point of the solution. You see, for a same solution, if the solution is same, then the elevation of boiling point, it is given by del TB, I into Kb into m, whereas del TF, that is depression and freezing point, it is given by IKF into m. If we number it as 1 and number it as 2, then you divide 2 divided by 1, then what will get? Del TF divided by del TB, then I into Kf into m, I into Kb into m. Therefore del TF divided by del TB equal to Kf divided by Kb. So for water, Kf it is 1.86 and Kb it is 0.52, and we know the elevation of boiling point because here boiling point of the solution is 100.68, that is del 0.68 degrees Celsius of this solution is increased. I think you cannot see the figure. You see, here boiling point of the solution it is 100.68, that is from 100 degrees Celsius of the solution, it is the boiling point of the pure solvent water, it is increased to 100.68. Therefore del TB here it is 0.68 degrees Celsius. Okay, therefore del TB here we can put 0.68. So if we put here 0.68, then del TF it will come out to be 1.86 into 0.68 divided by 0.52. Okay, if we calculate this one, it will be equal to 2.43. It could be 0 degree Celsius or Kelvin, whatever the unit you like to put, you can put. Okay, so again we know that del TF it is given by freezing point of the solvent divided by freezing point of the solution. So freezing point of the solution would be freezing point of the solvent minus del TF. For water, freezing point it is 0 degrees Celsius minus 2.43 degrees Celsius. So freezing point of this solution would be minus 2.43 degree Celsius. So this is the answer. Okay. So student, this is an number 3rd problem we are discussing here. This is a very important problem, and you should have a very good concept on elevation of boiling point and depression of freezing point. Okay, then you can solve this problem. So in the problem it is asked that arrange the following solutions in increasing order of their boiling points and freezing points. 3 different solutions are given. Okay, all the 3 solutions are solutions of non-volatile solute. In the questions, the concentration of the solutions are given here. So to solve this problem, you should have to establish a relation between the boiling points of the solution and concentration, and freezing point of the solution and concentration. Okay, so let us see what we got from elevation of boiling point. Del TB is equal to I KB and M. Again, this del TB, it is given by boiling point of the solution minus boiling point of the pure solvent is equal to KB into M. From this, when you increases this value, boiling point of the solution, this value will increases. In other words, you can say this TS value, that is boiling point of the solution, is proportional to the I into M, since this is a constant factor. Okay, similarly in case of depression of freezing point, del TF, we have got KF into M. Del TF, it is given by freezing point of the pure solvent minus freezing point of the solution. Okay, when you increases the freezing point of the solution, this value will decreases. When you decreases this value, then this value will increases. In other words, you can say the freezing point of the solution is inversely proportional to the I into M. Okay, so from the given solutions, from given data, we can find out this I value and molality of this solution. So let us see what are the value we can get. So in the first solution, what is given, it is an aqueous solution of sucrose. In the solution, it is given mole fraction of the solvent part, it is given. So mole fraction of sucrose would be 0.2. So for the first solution, for sucrose, since it is a non-electrolyte, Van't factor would be 1. Okay, and molality of the solution would be mole fraction of the solute divided by mole fraction of the solvent into 1000 divided by molar mass of the solvent. Okay, so mole fraction of solute, it is 0.2, 0.8, 1000 divided by 18. So it will be 13.8. So I into M value for the first solution, it is 13.8. Okay, so for the second solution, what is given in the second solution, just I think it is not visible earlier. Okay, for the second solution, it is given the 4 gram of sodium hydroxide and 200 gram of water. It is the solvent part, it is the solute part. So molality of the, for Van't factor for sodium hydroxide, it would be 2, and molality of the solution would be weight of solute divided by weight of solvent, 1000 divided by molecular mass of solvent. It should be molar mass of the solute. Okay, so weight of the solute here, it is 4 gram, and weight of the solvent, it is 200 gram into 1000 divided by molar mass of the sodium hydroxide, it is 40 gram. So if we calculate this one, we will get 0.5. So I into m for the third solution, it is 2 into 0.5 is equal to 1. Now we will see the I value and molality of the third solution. So for the third solution, it is given that it is a 4 molar sulfuric acid solution and this degree of dissociation it is 0.8 and density of the solution is 1.2 gram per ml. Okay, for this solution, the Van 't Hoff factor I would be 1 plus n minus 1 into alpha. Here for sulfuric acid n would be 3 minus 1 and alpha would be 0.8. If we solve this one, then we will get 2 into 0.8, it would be 2.6. This is the I value for the sulfuric acid. So molarity of the solution would be 1000 into molarity of the solution divided by 1000 into molarity of the solution minus molarity of the solution and molar mass of sulfuric acid, that is solute. So molarity of the solution it is 4000 into, I think it should be, it is not molarity, it is density of the solution. Okay, density of the solution it is 1.2 and molar mass, molarity of the solution for sulfuric acid, molar mass it is 98. So if we calculate this one, it would be 4000, it is 1200 minus 392. Okay, so it would be, if we calculate this one, we will get 0.49. so I into m for this solution, for the third solution, it would be 2.6 into 0.49, so it would be 1.3. okay, so I into m value for the three solution, what we have got, I into m value for the first solution it is 13.8, for the second solution it is 1, that for the third solution it is 1.3. These are the I value. So order of I value, order of I into m value, it is 1 greater than 2 greater than 3 greater than 2. Okay, so order of their boiling point of the solution, 1 greater than 3 greater than 2, whereas order of freezing point of the solution would be 2, 3 and 1. So these are their increasing order of their freezing point. This is the boiling point and this is freezing point. Okay, so this is how you have to solve the problem. I hope guys you have understand whatever the things I have discussed here. If you have any doubt, you can ask me in the comment section below, and if you are new to this channel, then don't forget to subscribe our channel and press the bell icon. So guys, this is it for the today's class. Thank you.